Hi everyone, this is Kasturi working as an assistant professor in the Department of Artificial Intelligence and Data Science, SNS College of Technology. So in this video we are going to see about virtualization system. So this slide introduces the topic virtualization system, which is the foundation of cloud computing. So virtualization enables multiple virtual machines, that is the VMs, to run on a single physical machine, making cloud services possible. Concept and architecture of virtualization. So virtualization is the process of creating a virtual version of a resource, such as servers. The resources may be servers, the storage, networks, and operating systems. So it allows multiple isolated environments to run on one physical hardware. So the core architecture includes physical hardware. It is nothing but CPU, memory, and storage. The next one is the hypervisor. So it's a virtual machine monitor VMM, and the next one is the virtual machines. So each with its own OS and applications, and in management layer for monitoring and resource allocation. So this architecture improves efficiency and scalability. The next one is the types of virtualization. So first one is the server virtualization. So it creates multiple logical servers on a single physical server. So it's mainly used for cloud deployment and data center optimization. Second one is the storage virtualization. It combines both physical storage from multiple devices into a single virtual storage pool. The third one is the network virtualization. So it abstracts physical network resources and provides virtual networks like VLANs and SDNs. Desktop virtualization. So it runs user desktops in virtual machines on central servers like the VDI, virtual desktop infrastructure. Hypervisor or VMM, virtual machine monitor, and its types we are going to see. So a hypervisor manages virtual machines by distributing hardware resources. There are two types of hypervisors. First one is the bare metal hypervisor. So it installed directly on the hardware. For example, VMware, ESXi, Hyper-V, Xen. It offers high performance and strong isolation. Type 2 is the hosted hypervisor. It runs on top of an existing OS like VirtualBox or VMware workstation. It mainly used for testing and development. So this slide explains about virtual machine lifecycle and its management. So every virtual machine goes through multiple stages. So the stage 1 is the creation of machine. So creation, VM hardware configuration like CPU, RAM and storage space. Deployment, OS installation and network setup. Third one is the running and executing VM perform tasks and applications normally. So monitoring tracks resource usage and migration, moving VMs between hosts, that is called live migration, and snapshot or backup or saving the VM state, and termination or deletion. So VM is switched off and resources are released. So this slide explains about the virtualization layers and architecture. So virtualization includes multiple layers: hardware layer, hypervisor layer, it's also called control layer, and virtual hardware layer like virtual CPU, memory, disk, guest OS layer and application layer. So these layers work together to allow multiple workloads to coexist. Full para and hardware assisted virtualization. In full virtualization, guest OS is unaware it is virtualized. So uses binary translation, for example VMware. In para virtualization, guest OS is modified to interact with the hypervisor directly. Okay, so it gives faster performance. For example, Xen is a para virtualized mode running hypervisor. Next one is the hardware assisted virtualization. It uses CPU features like Intel VTX and AMD V. It improves performance by overloading virtualization tasks to hardware. So next slide depicts the resource allocation and scheduling in virtualization. So hypervisors allocate and manage resources. First one is the CPU allocation. So shares CPU cycles among the virtual machines. Memory allocation, dynamic memory allocation by ballooning or overcommitting. And storage allocation, virtual disks are mapped to physical storage. Network scheduling, so controls virtual NIC traffic. Hypervisor ensures fairness, efficiency and performance. Security in virtualized environments. So virtualization includes new security challenges. For example, VM isolation. Each virtual machine must be isolated to prevent attacks from spreading. Hypervisor security. So the hypervisor is a high value target. Inter-VM attacks. So attacks between VMs on the same host. VM escape. So a malicious program breaks out of a VM to attack the host. Secure VM migration. So data must be protected during live migration. Security mechanisms include a strong hypervisor hardening, firewalls, IDS, IPS and encryption. So performance and overhead analysis of virtualization. It introduces overhead because resources are shared. Okay, so in order not to improve the performance, CPU overhead due to virtualization instructions, memory sharing may reduce the speed, IO virtualization slows the disk and network access, additional overhead in context switching between virtual machines. However, modern hardware virtualization reduces overhead significantly. Applications and the use cases of virtualization. Virtualization is widely used in cloud computing. So every cloud provider uses virtualization for scaling the resources. Testing and development side. So developers run multiple environments on one machine. Disaster recovery, creating snapshots and backups easily. Server consolidation reduces the number of physical servers. In virtual desktops, that is VDIs, companies provide employees access to remote desktops. Thank you for patient listening.